Hi, I'm Janine Cody, and this is the 8th in a series of 10 short videos addressing some of the frequently asked questions that I get about chromosome 18 conditions. And being video number 8, we've covered a lot of territory so far, so I won't recap it all. But one of the questions I get most often, which is a perfectly reasonable question, is why can't you just put back the missing piece of chromosome or take out a duplicated one? You hear about such things in the news after all, but there's one thing I need to point out. Those things you hear about in the news, those involve making changes to single cells in a dish. Just one cell where they attempt to add a gene, part of a chromosome, or take out part of a chromosome or a whole chromosome. Okay, there's a lot of difference between dealing with a cell in a dish and a person. And some of the obstacles to this, of course, are size. Now, first of all, what I want to make really clear is this is what we know today. Nothing's impossible. The day may come when you can do exactly that. Add back a whole chromosome arm or take out a whole chromosome, but that's not in reality at the moment. So what I'm going to talk about is what the current obstacles are. I never want to say something's impossible. Anybody who knows me knows that. But these are the obstacles, the challenges right now, is a chromosome deletion that probably includes, could be 50 genes, could be 10 or 5 genes. That's really quite large for trying to get into a cell. So those techniques really are not perfected yet. And so size is a big obstacle. The other obstacle is, of course, delivery, because these techniques that you hear about involve working at one cell at a time in a dish. So if you can do that to one cell in a dish, you still have to work out how do you get it to all the body systems, into the bones, into the nervous system, into the heart, wherever you need those genes to be working functionally, perfectly normally. How do you get that into every cell in a person that already exists? So that's another big obstacle. Seems to me, if you've been watching these other videos, since we really only think 10% of the genes are the ones that matter when you have a deletion or a duplication, it might make more sense to target those specific genes and the organs that they are functioning in or malfunctioning in. For example, if you have a deletion of 18q here, we know that really only a few genes are likely to be dosage sensitive, those that cause a problem when you have one copy instead of two. So why not figure out how to upregulate those specific genes, and only those genes? Or if for trisomy 18, for example, of a duplication, if there's a limited number of genes, why not figure out how to downregulate those specific genes? So that's really much more straightforward. Gene regulation is a common way to affect disease. Drugs can perform that kind of a function, and there's other techniques being developed all the time, antisense oligonucleotides or whatever that are being developed to regulate the function of genes. So when we're only talking about 10% of the genes, this just seems much more straightforward. And what you need to remember is that the normal chromosome is there, and it works normally. So upregulating a normal copy to do the work of two seems kind of straightforward. Again, there are few dosage-sensitive genes, and just upregulating or downregulating doesn't seem that impossible. And it may not be that you have to make one gene do the work of two. If you make one gene do the work of 1.5, that may be sufficient. We don't know. So these possibilities seem much more realistic. The other thing you need to remember when people are talking about genetic conditions is that people with deletions or duplications, these involve what we believe in most cases to be normal genes. So many genetic conditions caused by a mutation in a gene have a mutation that causes a gene to do something toxic. And we don't have that case. We don't have toxic effects to reverse. We just have normal genes to upregulate or downregulate. So, that's a pretty straightforward way to think about it. So, it is possible. It's going to be possible. We just need to keep working to get there. Thank you. And more to come.